Hello, everyone. Good morning, good evening. Welcome back. Welcome to Cloud and DevOps Batch 58. So before I start the session, I just want to extend my sincere apologies for the ad hoc leaves. So last 1 week was not productive. Out of 5 sessions, we just clocked only 2 sessions, and it's absolutely due to my personal commitment. I'm not able to deliver. I sincerely regret the inconvenience. I'll make sure there won't be leaves further unless until there is mission critical. Okay. So yeah, let's proceed. So any questions, anyone, before I proceed further? Okay, all right, let's get started. So the next thing that we want to do is we discussed about services, node port, external resource, external lanes, resource limits, requests, quotas, HPS, horizontal pod autoscaling, role-based access control is also something we have discussed. But how can we make sure, for example, if we land into a situation where, okay, here is a situation, okay, let's talk. Why this is not working? Okay, whatever. What happened? Why it is not working? Okay, all right. So I'll be using the chats, okay? So for example, you go here. For some reason, board is not working. Let me continue here. Okay, okay, all right. Let's get started. Even here, you should have the frames. Okay, that's fine. So let's assume this is your Kubernetes cluster. Okay, so in this Kubernetes cluster, okay, so we have our deployments running, right? So for example, if this is the namespace, let's assume this is catalog namespace. Okay, and let's say you also have a payment namespace, and you also have default namespace. Okay, so right now, if one service wants to talk to other service, they're talking to each other, right? So if you want to talk to one service, you say just say curl service name. But if you want to talk to another service, okay, you need to say what do you need to say? What do you need to say? You need to just say the fully qualified domain name of the service like curl, okay, service name, dot namespace dot svc dot cluster dot local, right? So likewise, what I want to do is I just want to make sure, let's say this is payment namespace, okay, and another is catalog namespace, default namespace, okay. Now what I want to make sure is, since by payment right now, if one service, they can directly talk to other service that is running in the other pod, right? Now what I want to do is I want to make sure, okay, this is a situation that I would like to implement, okay. Let's say, oh my god, okay. Now what I want to do is, okay, there are some limits, let's get rid of it. They have some limits, it seems. Okay, all right. Okay, now what I want to do is, let's say your catalog is running here, and you have your default, let's say Nginx pod running here. Okay, and you also have a payment pod running in the payment namespace. Now what I want to do is, okay, people who are trying to access, okay, this should not happen, okay, and this shouldn't work. So this should not work. And if you try to, if catalog wants to talk to this should work, okay. So this is the policy that I would like to build. So if you want to achieve these constraints, how can we handle it? Okay, how can we handle it? This shouldn't work, okay. So how can we deal it? Okay, and this should not work. How can we deal it? Okay, and this should not work. This should not work. Only this should work. Let's see. First, let's try to deploy the policy. Okay, so I drafted it in place just to save time. Okay, so what we are doing is we are creating a namespace called catalog, and we are also creating a namespace called as a payment. So we are creating a pod called as Nginx pod. Okay, we are creating a pod called as a catalog. Okay, and where are we creating it? Okay, we are creating a Nginx pod in the catalog namespace. Okay, and at the same time we are also creating okay, so we are creating a pod whose name is Nginx in the catalog namespace, and let's also try to create the name catalog. There is also catalog. All right, so we are creating something called as a catalog, and let's try to mail it as a catalog. App as catalog, and app is catalog. Okay, and no, we screwed it. Okay, let's go one by one. So we are creating a pod whose name is, let's get rid of it. Now what I want to do is I'm creating a catalog namespace and payment namespace. And at the same time, I'm also creating an Nginx pod in catalog namespace and the service also in the Nginx namespace. So what I would like to do is I can just change this. Okay, done. And this is payment. Yes. Okay. Now this is a pod. Okay. So this is a pod whose name is catalog in the namespace of catalog. And this service is catalog and which is deployed in the catalog namespace. That's it done. Next is payment. Okay. First, let's go here and try to put it here. Done. So this is the pod where you are creating whose name is payment and you're deploying it to the payment namespace and the label for it is payment. Done. Okay. Next, the name of the service is also something I would like to name it as a payment and just drag it as a payment. So you are creating two namespaces, two pods, okay, and two services. Okay. And at the same time, you're also deploying a debug pod with Nginx image. That's it. So try to publish it. Done. And go back. Alias, okay, bash network policy. Okay, now before that kc get ns, you'll see catalog namespace. Okay, nothing is there. Now I'll apply it. Apply cap. Now you see two namespaces, two ports and two namespaces will be created. Okay, you can see catalog and payment. kc get all -n. We can see one pod, okay, which is in the running state. You can also see one catalog, which is in the running space. And if you want to see this pod is serving, this catalog is being serving to that or not, you can do a describe. Okay, now you can see the endpoints of it, okay, is this. Okay, you can see the pod IP address is 35.58. Okay, and you can see the service is pointing to the same thing. Why? This is catalog. Why it is not pointing to this? App is equal to Nginx. Wrong, right? So app is equal to Nginx. This is something we missed. Okay, done. Okay, that's a mistake, by the way. Let's publish it. First, let me try to delete it. Okay, this is how you can validate. Okay, here there are no endpoints. That means this service is not really processing this particular node. Now, let's see. Get all. Now you can see the pod catalog in the catalog namespace, which is running and whose IP address is this. Now let's try to describe the catalog service and you can see the endpoint associated with this is 147.80. Okay, so perfect. This service whose endpoint is 147 and the pod IP is also 147. Perfect. So likewise, we'll also check whether it is the same with the payment or not. Okay, now you can see the endpoint of it is 34 dot not even here there is no endpoint for the payment. Why? Basic at all -n payment. Oh, app is equal to Nginx. Even here the same mistake. App is equal to Nginx. Yeah, I told you, right? Labels and selectors are very, very important. If you use labels and you use incorrect selector, so the combination will never work. So let's try to delete this. And also I don't want to do Vim. Okay. Now describe the payment. And the payment, why? Selectors app is equal to Nginx. Why? Oh, I didn't publish it. Okay, no worries. Describe the payment service, and you can see that endpoints are 149. Now let's try to describe the pod payment. Okay, and it should be okay, you can see 33.149, 33.149. Perfect. Now Casey get pods. What I would like to do is I just want to enter into this Casey exec. Okay, Casey exec debug hyphen curl. Okay, payment. Obviously it won't work because payment is in a different namespace. I'll just say payment dot cluster dot local. Now you should be able to access it, right? That means from the debug pod, which is available in the default namespace, you're able to curl to the payment. Perfect. Now, likewise, I'll also try to make a call to the catalog pod. Okay. Now, if you try to do this, it works. Okay. Now, what I want to do is I want to make sure, okay, when I try to make a call, okay, when I try to make a call, it should work. But in other cases, it should not. Okay. Clear. Any questions on this? Okay, perfect. Our board is also working. Let's take this back. Okay, see, man, see all these guys, how much they're my complicating. Okay, all right, never mind. Okay, so this is what I want to do. Okay, this, it should not work. Okay, this should not work. Okay, now you got the point, guys. This is in the default namespace. Okay, this is the default namespace. Okay, and this should not work, but the other should work. Okay, so this can only be done when you implement something called as a network policies. Okay, so there is a concept called as a network policy, just like how you define AWS security to the compute instances, what to allow, what not to allow. But for that, you need to use it. Okay, I already told you in the beginning, it's for these features to work, for the network policy to work, you need to have the network policy enabled. Okay, if you remember, for network policies to work, okay, you need to have the AWS VPC CNI enabled. I know we have taken a break, so I'm just trying to catch you up. And for this to work, okay, you need to have the add-on enabled, right? In our case, we have enabled the add-on. We have enabled the add-on, but we also need to tell, okay, to use this. Okay, that's when what we need to do is, I told for network policies to work, we need to ensure that enable network policy is true. Okay, and has to be added into the VPC CNI. So here, add-on, we have installed the AWS VPC CNI networking solution into our cluster. Okay, but it's just like system control install. It's not. It's like yum install nginx. It doesn't mean that you can use nginx. The package is installed just like that. If you select the add-on, that means you have installed it the cluster, but you really have not enabled it. Okay, it's just like yum install nginx versus system control start nginx. The only difference is you installed it and then you started it. Okay, so here just select this. There are some options. Okay, if you look at this, enable network policy true. This is something that you need to do. Okay, but how do I got it? Okay, this will take a lot of time. So that's the reason what I did was, if you look at this, there is an option called as AWS add-on. Okay, this is something we already did it last week itself, but we just need to come here, go to the configuration values, enable network policy is equal to true. If you make this, okay, if you make this, I repeat, if you make this, it is just like telling AWS network policy, the first one, this resource installs, and this value is going to make that enable network policy as true. How do I got it? Okay, how do I got it is from the documentation itself. Okay, that is the only thing I want to tell you. If you mention this, then that policy will be activated. Now, since you have enabled this policy, now it will work. Okay, I'm just trying to bring you up to the speed. Now, for this to work, you need to deploy the network policy. Okay, so we do have a lot of networking policies, AWS, Kubernetes network policy. Okay, you can define, okay, this namespace cannot talk to this namespace, or this pod in X namespace should not talk to pod in Y namespace. Okay, so for example, you are creating a network namespace, and that is created in the default namespace, and this policy is going to be applied to all the pods or the deployments that is having the label as role as DB, and this deployment and this policy is both for ingress and egress. And what it is going to do, it is going to block all the connections that are coming from this particular IP range apart from this particular range. So this offers a ton of IP addresses, and we are blocking everything apart from the small chunk. Okay, and this is going to be applied. Okay, this is going to be applied for all the requests that are coming from this particular project as well. And egress also you're mentioning, that means how the request has to go. Okay, the request can only be sent to this particular network against this port. That, okay, apart from that, it can't talk to others. Okay, you are restricting ingress and restricting egress. Okay, so but for our policy, I just made it a very small policy. Again, this is from the pure documentation. We are not bringing anything out of the box. Network policy. Okay. For example, you are developing a project. Okay, and you don't want ingress to be from anyone connecting to your namespace because you're just still developing it. You don't want to screw things up. Okay, so what you can do is you can deploy a policy, and what it does is it does default deny, and where you're deploying into the payment namespace, and what it does, it applies to match labels you haven't mentioned. That means it is going to be applied to all the deployments that are running in the payment namespace, and policy types ingress and egress. So that means ingress and egress is going to be blocked by default. Okay, so no one can talk to payment because we are denying default. Okay, and since it is applied in the payment, it is going to apply to all the pods. Okay, in the particular payment namespace. All right, now let's try to apply this. Okay, and it is going to be applied only to the new pods. So what I'll do is I'll delete this, and I'll try to deploy a network policy. Okay, there are no network policies that are available right now. Now I'll say CAF Now git pull will happen, and then it is going to create a deployment policy. Is it get pods? Now you see there is a policy that is being deployed, and where it is deployed, and it's deployed to the payment namespace. Casey describe you have deployed a network policy whose name is default deny and the payment namespace. You can see all incoming traffic. Okay, selected pods are isolated from the internet connectivity. All incoming traffic. Okay, selected pods will be disconnected from the egress connectivity. Policy type is ingress and egress. Okay. Now, they see get pods, right? Now, what I'll do is a curl. Now, from the debug pod, I'm trying to make a curl request to the catalog pod. Now, see whether you're getting the response or not. Now, let's say payment dot. Now, try to make the same connection to this. It will not work. Can you see this? You're trying to connect to payment. Payment will try attempt to connect to for some time, and then it goes for a timeout. And if you're interested to know how many hops it's going through, you can also give a -v. It shows you what's going on around. Okay, it is trying. It added some extra metadata saying that it is trying to connect to this, and it will fail eventually. That's right. Let's wait. See, it will never happen. Okay, the connectivity will never happen because of the network policy. Any questions on this, anyone? Guys, any questions on this? Want to take a pause? Any questions, anyone? Okay, all right. The next question is, okay, let's go to roadmap and see. So let's talk about monitoring and logging. So guys, monitoring. Okay, so in the space of monitoring, logs are very much important. Okay, so whatever our workloads are running in our Kubernetes cluster, we want to make sure, okay, for example, my master nodes. Master will have scheduler, etcd database, controller manager, API server, okay, kube proxy, kube DNS. We have a lot of components. I want to make sure I want to capture all the logs and present it centrally. The advantage is if you're on cloud, you get most of the things out of the box. Okay, in AWS cloud, if your AWS if your cluster is in AWS or if your infrastructure is in AWS, There is a service called as a CloudWatch where you can tell the logs that are coming from here, these particular nodes can be sent to a particular place and you can reserve there. Okay, how can you do that? So for example, you can come here, cloud trial. Okay, go here and not cloud trial, cloud watch. I'm sorry. Okay, log groups when it was created. So there is an option here, AWS log watch, that you can create. So you can create a log watch so that it can get that. Okay, did we enable it by the way? I don't remember. Uh, yeah, if you see this, okay, this is already enabled, defines the retention for the enabled logs. So not even here, there is that. So this is going to create a log group. Okay, so what this log group is going to do, AWS CloudWatch log group. If you select this, okay, maybe what I can do is I can just get rid of it. Okay, now what I want is I want to create a log group. So whatever the logs that are coming up, okay, log group, okay, just say EKS log group. Okay, so whatever the logs that are generated by the cluster, okay, you can see AWS CloudWatch log group. Example, name is AWS EKS. One second, you need to mention, okay, B58 EKS logging. So you need to mention the name of the logging, or so you can also just type AWS EKS logging. Okay, you also need to say plus Terraform. Okay, okay. So you can create something called as a CloudWatch log group. So you need to mention, is this the one? Yeah. So come here and you need to mention the name of the cluster. Okay. For example, here, AWS EKS log group Terraform example. Where is that? Let's see any examples. I want this to be for provides allow also, but where is the retention? Yeah, there's the one. Okay, so what we can do is we can mention AWS CloudWatch group. This is for EKS, right? So here you just need to mention the name of the resource that you want to target. If it is AWS EKS cluster, you need to mention the log name, I mean the cluster name, and then the retention. Okay, if you don't mention the retention, it will be coming up forever. Okay, that's what I did. So AWCK B58-EKS, the name of the cluster is also something you can mention. So in our case, the name of our cluster is B58-EKS. Okay, we can also mention that. Okay, and that's it. Now, so just publish it. Now when you try to change it, now it's going to update that particular log. And then going forward, whatever the logs that are coming up will be captured. Okay, but another important thing I want to talk about is you have you have enabled the logging, but whom you want to enable the logging. Okay, so as everything comes up with cost, okay, so how about pod scaling up, down? Every time pod goes up and goes down, I want my controller manager will plays a very important role. Okay, how can I handle that? Okay, let me show you all that. Okay, so there is observability, CloudWatch, manage logging. So here you can mention whether you want API server logs to be enabled or not, audit log should be enabled or not, or authenticator log should be enabled or not, controller manager log should be enabled or not, scheduler logs should be enabled or not. Okay, my controller manager logs are very, very important for me. Okay, because if a pod in the project goes down, you should know the reason, right? Root cause should be there, right? What will be the reason for that? Okay, whether it is a legitimate turn off or as per the standard it went down, we want to know the details, right? So we also have API server logs, and I also want to know the scheduler logs. So if you want to know what type of logs that you are interested, based on that you can go and enable it. Okay, you can go and enable it. So how can we enable it? Okay, so if you see, audit has been already enabled, right? How it was enabled, go to the logs. Here, if you see this enabled cluster logs, I'm only targeting for the audit, and that's the reason audit logs are coming up. And if you are interested about the controller manager, you can also do that. Okay, for example, I just want to enable audit logs of API as well, API server logs as well. Okay, uh, okay, there is an option called as a logs. Yeah, here is what I'm saying. So here there is an option for the cluster name. And yeah, here if you see API audit, okay, if you are interested about the other logs as well, you can also see what are the names of it. Since it is in the documentation as API, I just took it. But if you're interested, you can also find what other logs are available. API server logs, audit logs, authenticator logs, controller manager logs, scheduler logs. If you're interested about this, you can also put it. Okay, I'm interested about controller manager logs. Okay, you can mention. Okay, clear. Now let's publish it. Okay, now again, audit logs are enabled. Go here. Only the audit logs are enabled if you see this. Okay, now I am also enabling the controller manager logs. So from here, try to bash create. Now you can see they will also be coming up. All right, any questions on this, anyone? Taking a pause to take up any questions if anyone has. Let's wait. All right. Now you can see I have enabled other locks as well. Okay. Now come here, make a refresh. You should be able to see the other locks as well. Okay. So come here if you're interested about this. Okay. You can see all the locks here itself. Observability and is logging out here. Go to the logs, CloudWatch. Here in the CloudWatch. Okay. Go to the log groups and B58-EKS logger, right? Now it is coming up with a 1 day. Okay. Select this. You can see all the logs of it. Okay. Search all log streams. Okay. From last 30 minutes. You can see all the logs. And now why not? Because there is no event happening yet. Yeah, perfect. Okay. You can see all the logs that are created just now. Okay. So 22, 23, each and every event that is going on can be captured. Okay. Generated self-signed certain memory and all these things. Okay. This helps you in making sure if some event happens, you can just stream it. Okay. Clear? That is the advantage of it. Yeah. So next is in the space of observability. Okay, we are capturing the logs. So metrics. Okay, I think we have already deployed the metric server if I'm not wrong. Okay, metrics is to monitor CPU usage, memory usage, and the network usage, this KPI. So the basic metrics that are needed. Okay, but we can also gain more metrics using Prometheus Grafana. Okay, but for now, what we did was we have deployed the metric server, KC get, KC top nodes, KC top pods. Okay, so this information you are getting it through the metric server only. That we already covered it. Traces. Okay, this is a very important piece. Okay, but you don't get this out of the box. Okay, tracing is just like, okay, for example, let me take another big project, Stana. Okay, if you want to understand how the flow of requests are happening. Okay, so for example, if someone wants to make a payment, this is the flow. Okay, someone has to come here. Okay, hit the front end, and if someone wants to buy something, they search for the product in catalog, and if someone tries to add the item to the catalog, okay, so they have to be authenticated. So then it will be prompted with username and password. But the moment he enters the username and password, their credentials will be validated against the database, for example. And if it is correct, okay, he will get a prompt saying that you are authenticated and the item will be added to the object. And then the user has to make the payment. Okay, once the payment is completed, okay, an object will be sent to the queue manager, and then it sends an acknowledgement to the shipping. Then the user comes to know when the product will be shipped. So you have one request for if someone wants to buy a product, it went through multiple requests. And if you want to understand the flow of requests, you need to have a trace. Okay, so tracing is also very important, but again, this tracing is not much mature model at this point of time. On EKS as a whole, you don't get anything out of the metrics. But if you want something, you can use tools like New Relic, Dynatrace, Datadog. They play a very important role. And if you want to go through open source, you can go with Hager and Zipkin. But one thing I want to make it clear, uh, with respect to the Kubernetes components, I don't think it is a mature model at this point of time. Uh, Go through the stability. Tracing is still under active development and may change in varieties of ways. This includes span names, okay, attributes, instrumented endpoints. Until this feature graduates to stable, there are no guarantees on the backward compatibility. Okay, so in this space, open telemetry is a very good thing. A lot of companies like Datadog, Dynatrace, PagerDuty, everyone uses this open telemetry, and then they build things on the top of it. Okay, so let's not much worry much out of it because we have Neuralink Dynatrace, which is already doing the job. All right. Uh, any questions on this? Okay. Okay. All right. Now we already know what is HPA, right? What is HPA? HPA stands for horizontal pod autoscaling, right? Let's try to understand horizontal versus vertical scaling images. Let's see. Yeah, this is a good image. So vertical scaling, for example, if you want to change the instance type, okay, from T3 micro to T3 medium, that means it is the same instance where you turned it down and you change the instance type, it came up very big, right? This kind of concept is called as vertical scaling, and vertical scaling involves downtime because you cannot change it. Okay, and always servers with higher capacity comes up with a very big cost. In order to avoid that, what we can do is we can go with the horizontal scaling rather than creating a very big instance and making it as a single point of failure. What you can do is you can create multiple nodes, okay, and then put a load balancer, a device, okay, and then you hit it, and then the request will be sent to one among the backend nodes. This concept is called as a horizontal scaling, and this concept is called as a vertical scaling. Okay, so vertical scaling always involves downtime. I could see Grisha's hand raised. Yeah, Grisha, go ahead. Can you hear me, Grisha?
Sorry, Manoj, my mistake.
Okay, all right. Are we clear so far? Yeah. Any questions so far, anyone? Any questions? I'm taking a pause. Okay, all right. Let's proceed. So in Kubernetes also, okay, we have a concept called as a VPA. Okay, let's talk about it. Vertical pod autoscaling. Okay, VPA. It's also called as a vertical pod autoscaling. Okay. This helps in adding resources to the pod by taking. Okay, so that means you are running a pod, and your application is designed in such a way where it cannot work with multiple pods, just like a shared application. So in that case, for example, what you want to do is you want to add more resources to the same node or pod automatically. Okay, so that's when the vertical pod autoscaler comes up. In the vertical pod autoscaler, the same pod, okay, I mean, the pod will be taken down and a new pod will be coming up with new resources, bigger resources. Okay, you are going to define minimum and maximum resources like 100 CPU, like zero point 0.1 CPU to zero point 0.3 CPU, and 100 MB to 1 GB. So based on the needs, it goes up and down. Okay, so VPA always involves downtime. Okay, so VPA operates in two modes. First mode is manual mode, auto mode, automatic mode. So in the manual mode, pods will be okay, but involves downtime. So when you enable, you just get suggestions saying that okay, this pod can be taken up. Okay, this pod size can be, this is the average utilization. Based on that, you can size the resources. Okay, so for example, here we are using HPA, right? HPA only works when you define the resource limits and requests. Okay, without this, this is not true, by the way. Okay, come here. I forgot to tell this point. So you come here and just mention this. You need to define the resource limits and requests. Then only HPA will work. If not, okay, how does it come to know? We have mentioned 50% of the average utilization of CPU. But how does it come to know if you don't even define the resource limits or requests? Okay, but in VP vertical pod autoscaling, not VPC VPA. So how did you come to know these limits? Okay, you randomly don't pick it up, right? You use something called as a benchmarking. And as a part of the benchmarking, you should understand what your workloads are, and you run a lot of tests that defines what is the load, okay, and what is the resource utilization, and what is the memory utilization, all these things. Okay, you need to do some testing, and during the testing, what we do is we deploy the vertical pod autoscaler, just like HPA, VPA, in manual mode. So you let it run all the tests, all this is for 1 week or 2 weeks. After 1 or 2 weeks, you describe the VPA, it tells you the recommendation saying that, okay, this pod you have assigned 64, but it is just using 10M, maybe you can downsize it. Okay, memory you have given 250, 64, but we would need 250. So it gives you the recommendations. Based on the recommendations, we'll align them to these resources, to the pods. Okay, keep in mind, HPA and VPA cannot work together. Okay, so this is very important. Both HPA and VPA cannot be used for the same deployment. Obviously, diagrams, right? You cannot both expand vertically and horizontally. Okay, that's what it is talking about. Any questions, anyone? Okay, I will take it as no, but let's go here and see what it says as per the documentation. scaling. Vertical pod auto scaling. Yes, already done. Vertical pod auto scaling. Can someone come? Did we cover HP or not? Anyone? Did we cover HP or not? Grisha, Shailaja, Arun David, Harish, Mahendra, Mrudula, Rachit, Vikram. Did we happen to cover HPA? Yeah, all right. So this vertical pod autoscaling is a Kubernetes feature that automates the process of adjusting the limits for containers and pods. Unlike horizontal pod autoscaling, which scales the number of replicas of a pod, VPS scales down or up the resources of the pod's containers. It adjusts the resource limits and requests for each container based on its actual usage. If you have deployed with 0.5 CPU minimum and 3 CPUs as a maximum, and memory as 1 GB and a maximum as 3 GB, after 1 or 2 weeks, if you deploy it in a automatic mode, the values might up or downsized automatically, but on the not on the same pod. Okay, that's what it talks about. So yeah, limitations of VPA: do not use VPA with HPA. I already mentioned, which scales based on both memory. Okay, VPA might be recommended for resources then available in the cluster, thus causing the pod not to be assigned to the node and therefore never run. To overcome this situation, it is a good idea to set the limit range to the maximum. So EKS examples, how to configure VPA. So create EKS cluster, install the metric server. Yes, as I mentioned, for the HP and VPA to work, they have the HP, this one. Install VPA. What do they mean by install VPA? Okay, cluster config. Manage node groups. Okay, so this is something EKS CTL. Okay, EKS CTL is also a tool to create cluster resources. Okay, all right. So EKS control is also a tool. This is from VWorks. So this helps you in creating the cluster. For example, using the EKS tool, you're telling I want a cluster with this and this particular region and these many nodes. That's it. Cluster is created, but there is no concept of state. Okay, now kube control top nodes. There is no metrics error. This guy has installed it and get pods. Now keep control top pods. Next, install API, git clone, and then check out and then install it. Okay. But yeah, let's give it a try with examples. Okay. Auto scaling workloads. Vertical scaling. Okay, resize CPU and memory resources allocated feature. So this is how you can deploy. First, you have deployed something, and then you are going to deploy a pod auto scale rate. So for this to work, you should have, okay, it has been there from a longer time. So this is how you can mention. So what you are mentioning, I would like to deploy a horizontal pod autoscaler for this particular deployment. This is the name of the VPA, and I would like to create a deployment for this particular one and automatic mode. If you mention this as an automatic mode, okay, irrespective of the resources that you have deployed, it upsizes and downsizes it. Okay, this is very important to understand. Okay, but update policy. First, let me try to deploy a deployment. So VPA, right? So 0 to 3 VPA. So let's try to go through a HPA, right? So I'm not going to go through HPA. So go through this. This is going to create a pod. Okay. Done. So I have mentioned limits and requests. Okay. I have mentioned the limits as requests as let's say CPU as 100M and request as request 100 FT. We're done. That's it. Okay. This is going to create a path. And now what I want is I want to have a VPA. Provisions VPA. Okay, now what I would like to do is, I think they have mentioned something here, right? Copy this. What is the name? Front-end VPA. Okay, I would like to do this for the front end. Okay, this VPA is for the front end. How does it come to know? Okay, because you are clearly mentioning the name of it. Okay, fine. But what are the other options? Example. Hello. Okay, if you mention it in the auto mode, okay, it automatically upsizes and downsizes it. Okay, but this is what I was talking about. If you deploy it in the manual mode, what happens is, okay, for here, for example, what this guy done, okay, this guy has done in the automatic mode. That means it's going to deploy the policy. It is going to deploy and it's going to upsize and downsize, okay, automatically, okay, as per the resources that you have mentioned. But here, keep control apply -f. Once it's done, if you deploy it in the manual mode, it's not really going to change. All it does is it just makes the suggestions. Okay. So in these, since the time you have deployed, the lower CPU utilization and memory is this. Okay. Uh, this is what it went. These recommendations, you can see lower bound and target. So right now, what you have defined is this, but it went to this particular thing. Okay. So this is what this guy is explaining. This will give you an outlook that includes the current recommendations for the web app part. It might look something like this. Okay, the target values represents the current VPA recommendations. Okay, so these are the values that you have mentioned. Limits and requests. Okay, limits are half CPU and 128 MB. And what it says is the recommendation is 1 CPU and 256 MB. Okay, that's what. The target values represents the VPA recommendations. The lower bound and upper bound values represents the recommended range. Okay, where are the target? Yeah. This means the target values represents the current VPA recommendations. So it is recommending to change it with the 1 and 256, while the lower bound, which is nothing but this, and the upper bound, which is nothing but this, represents the recommended range for the resource based on the observed value. Okay, what is mean? Mm-hmm. Mm-hmm. So this is the okay. So it is telling you have deployed something, but as per my observation, define this as minimum values and define this as the upper values. That means define these two as the limits and requests. Okay, that's it, nothing else. Okay, please note that these are basic examples. I know that. Okay, all right. But I want to have an example with a container policies. Okay, let's ask ChatGPT. Kubernetes. Okay, no one deploys in production in an automatic mode. Okay, Okay, hold on. Okay, so you get ports. Okay. Now you should be able to see resource mapping front end hyphen VPC namespace. Where is VPC? Where did this VPC came up? Zero two three. Okay. Line number version autoscaling.k8.io. Okay. Not VPC VPA. Target. Okay. AK version app/11. This is a problem. Yeah, just a typo. Okay. All right. What it says, resource mapping not found. Keep control get VPA. Okay. So that means we need to enable something. How to do that? This is interesting. Something we are missing. VPA, Kubernetes, AWS, EKS. Again, you need to enable something on the. See, VPA don't come up out of the box. Okay, you need to enable something. Adjust pod resources with vertical pod autoscaler. So in this section, git clone, cd to this. Let's follow this. What this guy says. Okay, you need to do some changes, and what are those changes is something I'm interested about. Do a git clone. Okay, and then enter into this vertical pod autoscaler. Let it download. Okay, now cd to okay, cd to hack. Something needs to be enabled on the EKS. Okay, so this is distributed with the Kubernetes author. Okay, done. Script is equal to this. Okay, let's run it. We need to make some changes. Okay, we have not deployed any sort of Kubernetes. If your nodes don't have the internet access to the registry, I think our nodes have access to the internet. Okay, done. Now next, deploy the vertical pod autoscaler to your Kubernetes cluster control. Okay, done. Error from the server. Standard roles are not there. It needs some, yeah, I told you, right? Resource mapping not available for this. Namespace from standard input or custom resource definitions are available. Okay, all right. So there is something that we need to enable. What is that? What is that? Uh, So this is what there says. Ours is a private cluster. Error when deleting standard input cluster role bindings. So these roles need to be there, and for that, what do we need to do? Let's try with one example. What this guy is saying, horizontal point auto scaling, vertical point auto scaling. Okay, let's install the metric server. I do already have it. So install the VPA. Okay, let's see. I don't know why it's not working. See, but one thing, okay, you won't get VPA out of the box. It is an additional feature that you need to enable it. Okay, so I'll do it. So I just need to check out. That is the only difference between this and that. Okay, so here this guy is checking out to a particular commit and then running the same thing. Okay, let's see. So you can also, whenever the repositories are big, you can also go through a shallow clone. If you go through the shallow clone, it doesn't download all the entire commit history. Instead, just the last 10 commits you see, but you get the latest data, but you don't get the entire history, which is sometimes not really needed. Okay. So you need to go to the autoscaler. Now run this. Now you will be switched to the particular branch. Okay, not branch, commit. Okay, now cd to this. That's the only difference between that and this. cd2 done. Okay, perfect. So preview. Okay, done. Then I'm installing the needed VPA. Okay, let me try to add this. You cannot work or run VPS by default. I need to enable. Work. So you need to follow this. I think it will work. Okay, yeah. See, I told you, right? A lot of cluster role binding, custom resource definition is just like an add-on feature. For example, if in your company you are deploying, you are creating some features or creating a product, and that needs some features on the top of the Kubernetes, but Kubernetes is not offering. So you can create your own custom resource definition, just like how deployment is a resource. For example, if you are starting a company called as a testing group, testing group want to see, you can create a resource with a testing group INC. Okay, so it's just like building your own features on the top of Kubernetes. All right. So yeah, and once it is done, okay, now I just want to see the list of pods. Okay, perfect. KC get. This is what it is. Admission controller. Okay, perfect. See, I told you, right? Controller manager. You have a lot of features, but what we technically did is we have enabled the, okay, we have enabled the control, we have enabled the admission control for VPA. Okay, so VPA to work, we need to enable the admission controller for the VPA. Okay, upload documentation. Okay, so admission controller is just like a feature, by the way. Okay, so you can ask what is admission controller in Kubernetes. So a Kubernetes administrator controller is a piece of code that acts as a gatekeeper to Kubernetes cluster by intercepting and processing requests to the API server. Again, consider it as a feature. Okay, Kubernetes offers a lot of features. So if you want certain features to be enabled, you need to enable this particular admission controller mechanism. Okay, so if you disable a particular feature, Your QBAPI server don't allow. If you enable a particular admission controller feature, it enables that particular feature by the QBAPI server. Okay, simple. So done. Next, enter into this. Okay, so look at this. So here in the cube system, we have the metric server deployed because as a part of the cluster creation, and we also enable the VPA admission controller and VPA recommender and VKM updater. So these three have been coming through that. Okay, now. So what is the path forward? Okay, done. Then where is this Kubernetes tutorials? So demo example with everything configured. Let's take a basic example and deploy it. Since we already have from the repo, just change to the directory Kubernetes tutorials. Okay, Kubernetes tutorials. Vertical board autoscaler Kubernetes. Okay, done. CD to examples plus FNLTR cat redis.yaml. Okay, so you deployed the redis.yaml. Okay, fine. And then the vertical pod autoscaler in the this one. Okay, so what it does, it's going to, but what it is, whether it is in the manual mode or auto mode. Okay, this is another question. ls-ltr hamster.yaml cat. Okay, perfect. This sounds interesting. Now here you have deployed the vertical pod autoscaler. Since you haven't mentioned the mode, okay, so it is by default. If you don't mention, it's going to be manual, and at the same time you have defined it. So that means the policy values will be okay. By default, it is manual. Okay, if you want to be automatic, you can also keep it. But if you see the resources like this, that means the values needs to be updated accordingly. Okay, now what I want to do is I'll just come here and I try to mention these values. Go VPA. Okay, so everything is same. The only thing is I'm sorry, VPA apps deployment done. This is what I'm interested about. Resource policy. Mm, done. So what it does is it makes sure the values are upsized between this and this. Okay, automatically. But you cannot have both HP and VPA. That's the caveat. All right. Perfect. Let's see whether it works or not. I think this time it will work. Perfect. KC get VPA. Okay. Now you can see the front end VPA. You didn't see any more because we didn't mention it. Okay. Let's see. If you don't mention, what will happen? Nothing will happen. Let's try to do that. How to mention that? how to mention update policy. Just before the resource policy, we have the update policy, right? Yeah. Okay, I think mode, update mode. Yeah, update policy, mode is equal to manual or auto. Okay, so if you mention it as auto whenever, and this is going to be applied to all the containers that are available in this front-end deployment. Okay, and this is going to be upsized and downsized, okay, between the limits that you have mentioned. You have mentioned 150. Okay, this one, right? Now it's going to go in between 150 automatically. Okay, but it's not like out of the box, it goes for a downtime. Okay, so delete calf. Okay. Okay, perfect. Now you have mentioned it in the automatic mode. When you mention it in an automatic mode, whenever it experiences limits and requests, automatically it creates a new pod with new limits and requests by deleting the old pod. Okay, so yeah, but if it involves downtime, who the hell will use? We never know. It's all application demands. Okay, it's all about the application needs that creates it. But a lot of people, as per my experience, we deploy it in the manual mode. Okay, to see the recommendations. Okay, that's what we typically do in the organizations. All right, any questions on this, anyone? Any questions? Okay. What will happen? How cluster auto scaling works? Just like how pods HPA works, likewise within the limits of within the okay. What will happen if the pod that you are trying to scale, the big pod, and current pod cannot accommodate? Pod goes to pending state, and that creates an event to upset to add one more node. Okay. Now, what I also want to do is right now, my cluster configuration is min max. Where did we mention it? Yeah, max size is 3, right? Let's put it as 5 for, let's publish it, and let's try to create a pod with some bigger size. Okay. Okay. Heavy pod. What I want to mention. So right now, my cluster is coming up with okay, T3 dot medium, right? Which comes with the 2 CPUs, T3 dot medium. It offers 2 CPUs and 4 gig of memory, as far as I know. Yeah, 2, 3. Now what I'll do is I'll go here. I'll try to define the limits as 8000 MI and CPU as okay limits, and requests are, I'll just mention it as memory 6000 MI. Okay, so that means you are trying to schedule a pod that goes to the pending state. Okay, so GB cap. Now see what will happen. Pod in version 1. What the hell is this request? Pod in version 1 cannot be handled as a pod. How it makes sense?
Manoj, I think line number 15, it has to be
Sorry?
line number 16.
Okay.
16 line number. Yes.
Okay, got it, got it. Yeah, thank you very much. Yeah, I get it. Okay, perfect. So, okay, so you get pods, you see that the pod goes for running pending state because this, your pod is very small, right? Your pod is very big. So, okay, so you get pods. This will be in the running state. This will be in this state forever. Okay. Now, in this kind of situation, how are we going to handle this? Okay. So that's when in companies, okay, we'll agree to some standards like just like how we have small, big, and large. A lot of companies, what they do is either you have to use small pod or medium pod or large pod. Okay. So for small pod, this is the CPU and this is the memory. For medium pod, this is the CPU and this is the memory. And large pod, this is the CPU and this is the memory. This way, we can plan and we can tell to the teams if you want to create a pod or a deployment, you need to use either small, medium, or large. Small, medium, large are just names given to the combination of CPU and memory. This way, we can calculate the nodes and can act accordingly. Okay, so we'll see rest of the topics tomorrow. I think we are 6 minutes on the top of the schedule. So any questions, anyone? Okay, all right. Yeah, so going forward, we'll try to take as less breaks as possible because I have taken 3 days off in the last week. I'll make sure we talk as less as leaves as possible, guys. Okay, that's it. If you have any questions, you can on. If not, we are good. Thank you. Bye. Have a good day, everyone.